Hey there, welcome to the fourth episode of Radically Curious, a show that focuses on extraordinary human beings, their experiences, achievements, and things to learn from them to live a better life. Today, we're chatting with Chris Mattmann, Deputy Chief Technology Officer at the NASA Jet Propulsion Laboratory, responsible for AI division and everything data science when it comes to space exploration and missions beyond our blue planet Earth. He's a professor of computer science and a major contributor to open source software. He serves as a director at the Apache Foundation and actively contributes to multiple software projects, including Hadoop, Tika, Solr and Lucene. Don't forget to like, subscribe, and comment on the most interesting parts of the conversation. Thank you and enjoy. Welcome to the episode 4 of Radically Curious, and here we have Chris Mattmann with us, and welcome.
Hey, thanks for having me, Art. I really appreciate it, and happy to be on the podcast.
Nice. And you work at NASA, right? JPL, Jet Propulsion Laboratory, and you're the guy behind all kinds of AI applications in space, right?
Yeah, I've been at JPL in Pasadena for about 20 years. It's so NASA has a bunch of different centers throughout the country in the U.S. and all of those centers are mostly places where government workers work. There's civil servants and so forth. At JPL, we're unique. We're NASA's what they call Federally Funded Research and Development Center, or FFRDC. And so a lot of the government agencies have what they call an FFRDC or a national lab, or even several of them. They've got them in DoD. They've got things like MITRE, or they've got Lincoln Labs and things like that to work in defense. Department of Energy has Lawrence Berkeley Labs, things like that. So NASA, we're unique. We're with NASA's FFRDC. And so we are actually Caltech employees, that work there for the California Institute of Technology. And so my role at JPL is I spent about, real quick, 15 years or so helping to architect and build instrument and science data processing systems for Earth science and planetary missions. I was the chief architect in that division. Over the last probably about 5 years, maybe 7 years or so, I've gone from there into more technology development, and now I live in IT. I run our AI analytics and innovative development division or department. We enjoy data viz, AI, ML for a number of different customers.
Amazing background. And it sounds like, you work in an environment where there's so much convergence of like different disciplines and different people and different approaches, and kind of, you mentioned that you're actually Caltech people. So it's kind of like bridge between commercial, science, all kinds of things, right?
Yeah, exactly. And, what we say is we have these thematic areas. We've got, one of them could be kind of this cross-cutting type of thing. JPL is NASA's Center of Excellence in robotic exploration of space. And so where are the main places we're putting our focus on that right now? Places like Mars, right? We have a huge Mars program. That's where most of the robots, we're about to next week ship out from the Cape, launch our rover, our Perseverance rover, which is Mars 2020. It's a car-size rover that will be just like our other one, Curiosity, and has a whole host of science experiments.
Rover?
Go ahead, Art.
Have you worked on Curiosity?
Yeah, our team worked on a couple different areas for Curiosity. One, as an example to show cross-cutting, imagine the clean rooms and where they build parts and stuff, and they're wearing those bunny suits and stuff, right? Well, one of the use cases in the clean rooms is that they don't want to contaminate stuff and parts that go to other planets, because we don't want to act like we discovered life when it was actually, yours and my skin cells that shed onto it. So they've got these things in the sensors. They've got these big, I'll say $20,000 sensors that we got about 3 on labs deployed in clean rooms, and they do very, very precise measurements like that. One of the things my team worked on is we asked the question, could we do it for a couple $100 using sensors that weren't exactly as good, but maybe a couple percentage points less? And so we do a lot of Internet of Things edge device stuff too. So we built a project called Clean, which is a IoT Raspberry Pi, a couple different sensors on it, temperature, particulates, things like that. Provides those measurements within a fraction of the same accuracy and things like that those big 20 grand devices cost for about $200. Link them up to an Amazon dashboard, a cloud dashboard, and network. and then boom, we can give more situational awareness. We can do it for tons cheaper and things like that. So that's our clean environment sensor. That we use that for 2020. Make sure we don't contaminate anything. Another area, real quick, since we're on the topic, is okay. So imagine today that rovers and things like that, they run off of, and space assets, but let's talk rovers on the surface. They use a processor on it that's like an iPhone 1 processor. And, you know, Art and I work together on things for your listeners. We've worked on this Corona Y stuff. Art likes GPUs. He likes new stuff. He doesn't like iPhone 1 processors. Those are old. Why are we using them? The challenge related to that is that we can't use newer processors yet, because for us at NASA, Civilian Space Agency, we're risk averse. So when we crash something, it can't be like the Dragon or, you know, anything like that. And it's like, sorry, you know, and whatever, and we lose money. When we crash things, there are congressional inquiries and things like that. And so we're very risk averse. And so we only use things that are radiation hardened. You know, in other words, that when we put hardware into space, cosmic radiation hits it and it does wacky things, like it flips bits, it does. So we want things that are radiation hardened. And so the RAD 750 is like an iPhone 1 PowerPC processor, maybe 20 years old. BAE Systems helped build it. And we use that on all of our things. So most of the machine learning that you see today is human in the loop, a lot of it, and autonomy and things like that. But tomorrow, we will have high-performance spaceflight computing, GPU-like multi-core chips and things. Qualcomm Snapdragon is an example of that today. That's not as radiation hardened, but they're working towards it, but it's still usable. And we have that on our Mars helicopter, Ingenuity, which is along with our 2020 Perseverance rover that will fly the first drone on Mars. We're also experimenting with other HPSC things. So in those use cases, one thing that my team helped to do is help think of killer apps. When we can run GPU, deep learning type of things on board now, which we'll be able to do with the next rovers and in the future post-2020, what types of apps can we do? One of them is drive-by science, computer vision. You know, so the rover sees things, it's taking images from its nav cam and mass cam at high frequency. When it sees things, why does it have to send us 200 images back a day to use for surface ops planning, when instead it could send us back 1 million image captions and run Google's show and tell model, you know, and do image captioning and give us those, because text is cheaper than images to send back. And then also tomorrow, if it sees in the distance that it's going to be sandy, you know that the motor is going to spin the wheels more because it's going to be harder to catch. Versus if it's rocky, the power, you know, it's going to expend less power because the wheels are going to catch. And so we have energy aware optimal auto navigation as another use case we've been helping them build. The idea there is that basically in the future, rovers will have to drive a lot farther and faster, you know, with things that we're planning. And so those are some of the things we've been helping them work on.
That's so much stuff that I immediately want to submit application for your, you know, JPL. Like, it sounds very exciting. And man, like, even from the first thing that you mentioned, so to say your main responsibility is like, make sure there is no coronavirus on Mars, right? In a way.
That's absolutely right. That is absolutely right. Let's not contaminate anything.
Yeah, makes sense. But the second thing, and you know, the second scope of things when it comes to AI and data science, it's just fascinating when you think about different type of constraints that, you know, another planet will have or space will have, because we're also kind of glued to the reality that, hey, we're kind of like hyperparameter tuning and blah blah blah, but all these things that we're dealing on a daily basis as machine learning engineers. I mean, in space, when you deal with radiation and kind of second order consequences of a completely different planet, you have to deal with a completely different set of constraints. And even in terms of the data transfer, right? I mean, just sending images through, I don't know how many kilometers, thousands of kilometers, but like it's definitely something to optimize your data processing pipelines around, to optimize the actual on-premise calculation and things like that. And it's not like you can expand your, you know, rover or helicopter with some more resources.
That's exactly right. And let's make explicit what you were basically describing, and what I kind of, you know, implicitly was alluding to is the bandwidth is an issue. So every time we feel like we have instantaneous access to deep space and other planets, and actually because of one of NASA's crown jewels that's used internationally, so not just by the US, but all nations use NASA's Deep Space Network. These are 3 70-meter dishes, amongst other things, that are carefully positioned in Madrid, Spain, Canberra, Australia, and Goldstone in Fort Irwin, California. And these are basically how we do deep space. It's radio-based communications. NASA is experimenting and looking at things like optical and having optical deep space comm and all that, but today it's radio-based. These are the crown jewels. This is how we communicate. And in that, unfortunately, radio is not light. And, radio waves are fast, but they're not fast. It actually takes 8 minutes round trip time to communicate between Earth and Mars. So you said, Art has an idea of a command he wants to issue, so he does it. He issues the command, and he does not get confirmation back from, Mars for 8 minutes, and so we typically queue up a ton of commands and things to send, and then we wait to kind of hear back. So there's a really famous video from the 2012 Curiosity landing, which was our prior rover. Mars 2020 Perseverance is the same size, but has a tons more instruments and other things on it. During that Curiosity rover, it was called the 7 Minutes of Terror. You can look it up on YouTube. And the idea is, during entry, descent, and landing, EDL, there are these 7 minutes of terror in which the rover's got to do, especially with one that's car-sized, like a Volkswagen Bug, like Curiosity and now Perseverance. They actually invented a new EDL mechanism. It's like a sky crane. It's straight out of a movie. It's like, the rocket shell's coming down into the planet, blows off the heat blasters, it gets down. It literally has a crane with retro rockets that lower the rover and retro rocket and have to carefully, it's got AI and other systems on it that are, monitoring its, altitude and where it is and when to fire those rockets, when to drop a big Volkswagen Bug without damaging it in any of those instruments that we just, paid billions of dollars for it to, egress from, Earth into Mars. And so, yeah, they call it the 7 minutes of terror because largely, almost 100% of those actions occur in this window where latency is an issue, And it's a fascinating video. I recommend your viewers and you watch it, and you'll enjoy it.
I'll check it out. And I mean, the things that you're describing, they're exactly the type of things that you have to be risk averse to, right? Like you have no chance of, allowing a marginal error in those computations. So how do you deal with that threshold? I mean, essentially, when you're creating AI applications, it's not like you can achieve 100% accuracy, right? So where is that balance for you guys?
Yeah, so for us, and I think you and I see this in AI too, you'd probably agree too, but there is this movement even in AI. There's definitely data science in AI, and there's research data science in AI, and there's a difference between research models to what the big web properties and other people are doing with productionized operational research. They still do research, but to productionize things, you might need to, that's why you have these amazing stacks, the TensorFlows, the PyTorches and whatever the world. How do we, get that at scale at Facebook and Google and all that? But so just like there's that similar movement into engineering ML and all that in AI, for us, it's not a movement. Yeah, it's just part of our DNA, at JPL. And so we call that really end-to-end formulation. And what it means is that we have a concept shop at JPL. So even from the early, days, of missions, we formulate them through conceptual designs and ideas, and then we apply rigorous, really engineering process to that. So it starts out with napkin, back of the napkin types of things. We have a team called the A team, that does that. Their job is to pull SMEs inside and outside of JPL to think of the next missions 20 to 30 years out. That A team and Foundry, we have an innovation foundry, their job is then to take it to what we call Team X. And what they do is that they start to apply rigorous engineering and software models to those whole mission, whole cloth ideas. What types of measurements do we need to take? What types of, how do we protect the planet? How do we, ensure space junk is not just, all of that, take all of that stuff into account. And that's all sort of environmental, external to what you and I sort of cut our teeth in, which is the software. Then there's this whole software reliability. And so all of that is formulated through Team X after the Team A design and rigorous engineering process, which may take months, is done in a study. Team X takes it, they apply real cost models to it. Hey, what's the cost realism of this? Is this something we're going to need one or two administrations to fund, or commercial industry needs to develop this technology to do XYZ, or we need to partner with another center? comes out of Team X. Only the best come out of Team X. And the idea is from there, we typically have a pipeline or a connection to what we call the decadal surveys, which are the recommendations from the NRC, the National Research Academies, for what we should do across sciences, what types of measurements we should take, what do we need to know, either about ourselves, the galaxy, other planets, Earth, over the next decade. They publish
philosophical questions.
Yeah, they publish a decadal report once a decade in Earth and planetary, and those inform those Team X, really cost models and design. And then, so once it gets to formulation, if we're lucky enough to get a $100 million mission, a 10-year, billion-dollar Mars mission, whatever, these national crown jewel things, then JPL is already primed. By the time we're funded, we're already in phase A, B. We've done an early design review, critical design review. We bring experts inside and outside of JPL, and we really formulate this thing. And JPL follows a phase model. By C, we're into critical design, core design. By the time we get to phase E, if we pass all the gates, and we've turned things off before, because like, in risk-averse, you need to be willing to turn things off, and if it makes it to phase E, we're operating it. It's flown, we've launched it, we've partnered, and that's the operations. And typically that follows the budget cycle too. There's more money earlier on. It's typically kind of waterfall-y, down less later for operations and stuff. But, JPL is also, and NASA are one of those places, and you'll laugh at this, that we say it's going to operate for 3 months, and 10 years later, it's still working. And it's because we put in that rigorous design. And we can typically get the project to keep going if it's adding science value.
But it makes sense, right? I mean, especially if you deal with situations that haven't been observed before, right? And when it comes to AI and machine learning, and there is, there are different types of movements right now. And the primary one, unfortunately, is just like a statistical representation of reality, right? That's where all the deep learning and all the, amazing techniques are being deployed. And how do you deal with that? Like when there is no statistics, when there is no data that you've previously observed?
Part of it, I'll get a chance to plug our, partnerships, some of the things we've worked on. So some of my JPL people worked with Art and his team on Corona Y. And part of it, one of the earliest things that we did, our contribution to the stuff they're doing studying COVID, it was what I'll call exploratory data analysis or feature generation or things like that. And so part of it is that it's that our team, so that's JPL as a whole. I talked about that. Now let me talk about our team. Our team, I like to think about it in a phased, complete whole cloth type of way too. So we don't just have, I have a couple of people at JPL I would say could work at Google DeepMind, could work at these center of excellence type of places. That's what they love, deep learning and this and that. But I've got a ton of people that could work at the New York Times or work at the Guardian, tell data stories with D3 and Plotly and things. I've got a ton of people that really just want to do data analytics. They want to do exploratory data analysis. They want to pull up Tableau. They want to generate features, use SciPy. They want to use TensorFlow, whatever, do the feature analysis, the extraction. And then we've got people that want to do it on the edge with IoT, in the cloud or whatever. And so I like to think of our team as complete in that way. And because if you just have one, they might be over biased, like you said, and you and I know this, like the hot thing now is, deep learning is going to solve everything until you try and explain it, and to your, point is like, yeah, you might not even be able to explain it or have statistics and so on and so forth to do that. So I believe that ways that you do that are doing exploratory data analysis, understanding you do need to really, my recommendation, all data scientists, machine learning people nowadays are understand what a hidden Markov model is, understand what regression is and classification, because if you, two other things. I'm writing a book right now, Machine Learning with TensorFlow, second edition. And if you follow the progression of the chapters in that book, we start out with really explainable models and explainable classical statistical machine learning. And then we get into CNNs, deep learning, things like that, LSTMs, RNNs, and generators and all of that. And, to me, I think too many people, and I saw some head nodding on your part, so you agree with this, hopefully. Too many people nowadays, they jump straight to, wow, let's throw some, networks at it and whatever. And they're like, cool, why is it doing that? You know what I mean? And so anyways, yeah. So for me, I think that more data scientists, more AI ML engineers need to study those explainable models. And so, by the way, there's even a DARPA program. There was a DARPA program in that called XAI, which you're nodding your head, you're familiar with. And that was a good thing. I mean, we need more of that.
Yeah, it's interesting. The explainable AI started, years ago, and it doesn't feel like there was much progression in that area for the past 5 years. Especially, it kind of looks funny when you observe all of these movies and shows that attempt to solve it. Like WestWorld, by the way, a great example of explainability. I'm not sure if you saw the show.
I love it, HBO.
Yeah, that first season where they had the debug mode and just like explainable flow of how the machine reached the conclusion. Like, it's crazy that it's already like in shows and it kind of assumed to be a thing, but no one works at it on scale, And there are initiatives in DeepMind and others that are attempting to solve it, but it's not mainstream.
Yeah, and I got to throw a shout out to Evan Rachel Wood, who I love on WestWorld, since you brought it up. I loved her on True Blood and some other things she did in the past too. But I completely agree. So you and I know they're only so sometimes people tell us, they talk to me too. Oh, you work at NASA, so you must have access to all this computing and stuff. We have computing, and we do, but we're not necessarily using it in some of those ways like they're using, and at the scale for ML and ML ops. I would say the earliest, we talk about technology readiness levels at NASA, TRL 1 to 9, 9 being it's deployed and flown, 1 being early stage research. And then there are phases of that, 1 to 3 usually, then 4 to 6, then 7 to 9. And so I think ML ops is really at that kind of maybe like 2, 3 TRL level at scale for us. Many I see over the last 5 years, lots more ML use, lots more people, even during COVID, lots of people, how can we use NASA satellite data to do, COVID level ML stuff? That's great. We need to be doing that. That's awesome. It's still at the level of, I'd say TRL level 1, 2. It's not ML ops, but it's yours and I job to help that and the community and things like that. We got to show them because we've done some ops stuff before and we know that in other contexts and we got to get it there. So.
Yeah. And it's interesting to hear you say that because there is a big part and there is a segmentation, right? The AI industry of the past, 5 years started to segmenting so deep into like ML ops, the data modeling, the actual, infrastructure for labeling, annotations. There are startups that are raising hundreds of millions of dollars just to focus on like data labeling or very specific part of the machine learning pipeline. But there's not much, again, happening in the, causal inference type of area or startups focusing specifically on that because, the industry demands classifiers that can, detect cats and dogs, not explain what is a cat and like how did a cat become a cat or things like that.
Right. And what Art's bringing up for his listeners too, just to kind of highlight that, is that normally ML, we talk about in explainable land, if you reverse the process as opposed to what we do in DL, deep learning and whatever networks, is that normally you start out with feature engineering. And the features explain why the cat became the cat because you talk about the things that, you talk about the things that make up the cat. The fact that it has whiskers, the fact that, it's got pointy ears or this and that. And we start from that perspective. In networks, it figures out very awesomely and at scale that it's a cat. But then the struggle is, what do those layers mean? And why do certain layers imply those features? Because they're really a black box. And so that's the point that Art is making. And there is a lot less work in causal inference and things. I agree today. Maybe you'll agree with me, and this is a good pivot or continuation, but we can talk a little bit about this for what you think. I see a big effort in industry right now that it's very expensive to capture and collect machine learning training data. And that's why, to your point, there's these $100 million investments. There's these huge investments, like you said, in VCs and just labeling data. And so the challenge that they have there, to me, is domain adaptation. And it's that in cat dog domain, it's very cheap to collect labels. It's a cent per label. We know cats and dogs. We can do that. But let me give you a for instance and tie this back to NASA. Part of that, so take that drive-by science example that I was telling you, the rovers driving, and we want to recognize regolith and bedrocks surrounded by outcrops, because that might mean there was water there. And what that is you can treat that in a way as an image captioning or image labeling problem. It's captioning only in the sense that we care about language, because we care about things like cardinality, how many outcrops, and we care about distance, is it near or close to the bedrock, and whatever, right? So dimensionality, spatial dimensionality, cardinality, they matter, and so that brings language and not just labels. And so we've built again, using Google Show and Tell algorithm, a neural image caption generator. We've done that for planetary science, and that's one of our key algorithms. We call it Scotty. They're named after Star Trek characters. We've got Scotty, Uhura, and some others. Shout out to them. But in Scotty, one of the challenges that we had is labeled data collection, because we had to do domain adaptation and transfer learning, because we start out with image captioning, which uses the Flickr 8K dataset, very generalized images. So what that captures and relationships that we like, that we want to transfer, are the learned relationships for cardinality, locality, and stuff. And we want to retrain the labels, which are the first part. If you study Google Show and Tell algorithm, it's got two networks. It's got a labeler, which is like MS Coco, or you can use any of the other ones like VGG or ResNet 50. And then it's got an LSTM RNN to learn the language and the semantic relationships, basically for cardinality and distance. And so we retrain the labeler. We can still leverage the second learn part of the network, the LSTM. And so we have been using planetary geologists, many of them over the last 3 years, and at immense human labor costs, to curate and collect captions, that are scientifically valid. Because it's like flying airplanes. It's like you can't put something on a Boeing, 757, 767, 777, 787. That's half-baked, as we've seen when things happen, related to that, because human lives are at stake. So for us, it's kind of a different problem, but equally as important. We don't want to make a scientific discovery that's false. It would ruin our reputation. And so for us, scientifically valid captions are what we need if we ever allow the rover to do purely autonomous things with human-in-the-loop inspection after. And so we've paid a ton of money, basically in labor and cost and whatever, to curate and capture these labels just to do domain adaptation and transfer learning. And so what if we didn't? What if there were zero-shot, one-shot techniques? What if there were better ways of doing that? And there's a lot of research in the industry to do that right now. That's a hot reason why labeling is important and things like that.
Yeah. And the adaptation in general is a hot topic, because, there is this utopian kind of dream of creating the AGI, right? And I wonder what you think about it, because it's actually everywhere in the news with the GPT-3 and all kinds of amazing things that it can do for humanity. There was this article that I just saw that GPT-3 can now design websites and prescribe medicine. And I was just like, what is going on? Just like, come on. But like that's the problem of the hype, this new kind of, it's crazy that it resembles that, but it feels like there is a cult of AGI, And
I think there is. Yeah, keep going.
Yeah, and there is this kind of notion that, hey, we should just dump as much money as we can to create this good version of AGI so that we don't have SkyNet. But it feels weird even to think about that. But then you start thinking about all the feedback about the GPT-3, and you start realizing how much there is a perception that you can reduce the human part of it just to a billion parameter system, and kind of like going into this theorem of infinite monkey. It's basically there is a chance that this model can produce a very conscious text, but like, is there a point in it? Like, what is the intent of it creating that text? So I would love to hear what you think about.
Oh, you nailed it. You're talking. Your basic argument that you just made is that the domain is the problem is what matters. It doesn't matter how interesting or underlyingly powerful the network is, or the intelligence that we create. So it's absent a problem that's important, then why are we doing it? And who cares? And what does it matter? And so this is the tool use problem, that I agree with. If you ask me what's real today and what matters about, and is SkyNet coming? And by the way, everyone forgets we won. As every Terminator movie I saw, we win at the end. So yeah, Arnold to the young guy, Eddie Furlong, who's big now. I'm sorry, I'm a child of the 80s, but I know some of the new Terminator.
Yeah, Rise Against the Machines.
Rise Against the Machine. Exactly. We won that, man. Robert Patrick's still alive, but his butt got kicked, by Arnold. And so, but anyways, the real things, in my opinion, related to that are the real problems. So you asked me what's going to be cool in the next few years, like smart cars, computer vision, smart trucks, supply chain, big disruption there. And so that's why people are so concerned with job retraining on some of these, say, computer vision driving jobs. Those are real. The smart cars are real today. Smart trucks will be real, soon. There's going to be 1 million truckers that are really out of work. And you know what? My answer to them, I think it's intellectually lazy to say we're going to retrain all of them to learn how to code this and that. That's not the right way. But we need to think about what skills they could. Should we be gathering SME knowledge from them? Should they then go into design of things that are really difficult, hard? Like, say, take a quantum computing problem, a big, heavily constrained problem with like soft constraints and things like that. Well, those are decision-making problems. And we don't have quantum today. It's awesome, and people are researching it, just like 5G and, Wi-Fi 6 and all of this and whatever. But that's like later in the tech waves. So we don't have it. And because we don't have it, retrain the truckers and the people to do those types of hard constraint problems that our brains in humans are still good at. And so take a problem like that, or take another real problem like what you guys are doing in Corona Y, where you're researching COVID. There's a lot of EDA mixed with, end-to-end pipelining and things like that. That's, doctors love that stuff. Intelligent assistance, not replacement. Those are other ways you can retrain people's skills and do all that. So yeah, I see all the hype machine. Now, the hype machine can be used in a bad way too, where they're like, oh, Elon has a problem with GPT-2. He thinks it's too powerful. And, oh, AI is going to, and we hate that. You're laughing. It's the same way that you introduced this conversation, because it's taken out of context. He did not want to release it. I mean, give me a break. It's this type of stuff. These are good tools. It's the application that you use it for.
Yeah. And especially when, right now the GPT-3 is in beta, which means only limited amount of people can use it. But is it really the best way to distribute this access? I mean, the people that are hyping up the machine right now are basically clueless. They're just posting these weird, excerpts from the results, and it is a worst way to distribute something, even if you think or consider it powerful.
Yeah, and that's this, and I don't know how much you've seen this dichotomy in your work over the last 10 years, but I've seen this 10 years ago. People would ask me, we've got, some very senior statisticians at JPL, like pure trained statisticians. And then we've got some, fairly senior as well, but, machine learning people. And people would ask me, what's the difference between like the UCLA stats PhD person and the machine learning people? The thing I see is if you look purely at the productivity of the machine learning people, they're cranking out papers, they're going to conferences, they're making software. And you take the statistician who publishes a paper every 3.5 years. And when they do, it's like an uber rigorous, mathematically, and so people would say, is that statistician not as productive, as the machine learning person? And, and then the statistician, if you'd go talk to them, they'd be like, those machine learning people, they have like an idea or a breadth and they publish it, and, and so they've got these like different things. One thing I've seen is the answer is more likely kind of somewhere in the middle, like everything in life, and it's kind of what you just said. It's like these people that get a result with GPT and then put out a notebook and they're like, oh, and there's an article written about it. There is such a thing as fake news, or, fake news, not necessarily in the way it's politicized, but you could call it hype cycle and, whatever. There's that. Versus, say, some of the stuff where you guys talk about what you're doing in, say, Corona Y, or you talk about something else where you kind of got a result that you could talk about and know a little bit more. That's kind of the in-between, right? You don't take 3 years to do it, but you don't want to, every time you sneeze, publish what you're doing,
Yeah, and there is a balance to it, right? And there is also like this notion that, hey, it's beta and we'll only release it for a limited amount of people. But like, how can you determine the actual like use case based on just two sentences in application? Because I did submit the beta for Corona Y because there's a legitimate use case of the NLP analysis and answering researcher questions, and I do feel there will be a very useful application. But then I go on Twitter and I look through thousands of images, like screenshots of the text that GPT is producing, just like meaningless stuff, or just conversations about God, consciousness, and all of these things. And I'm like, why?
I know. It's kind of like me. I had to tweet when I was starting my real foray. I've only deeply been involved in machine learning, I would say, for the last year and a half, 2 years. And my thing for me was I would always call myself an information retrieval person, data science, open source, that type of guy. But the last couple of years, I've gotten heavily involved into machine learning and AI. And one of the reasons was I was sick of not understanding what my people that work for me were talking about. And I'm the type of person that, that can happen for a while. And it had been 10 years since I wrote a book, and I was reading some good machine learning books. And the first edition of the one that I'm writing now was really good. It was written by a UCLA PhD, computer vision, Nishant Shukla. He graduated in 2017, went into startup world, and has been doing a great job then, but he doesn't have time to do book stuff anymore. And I started asking him a bunch of questions on Twitter and asking about his book. And I realized that the only way that I was going to get the deep understanding of this was to treat it like I teach at USC too. I teach graduate computer science classes there, was to treat it like a class. And so every little suggestion at the end of the chapter, like, hey, you could try and build a facial recognition system using the CNN, rebuild VGG face. And then I went and did it. And 9 weeks later, I'm like, holy shit, this is like a graduate, assignment. This is a lot of work to understand this. And so when I did that and I started, going down that path, I realized that a lot of people, when you're searching for information like you were out there, just put stuff out. I was even doing it. I put my first CNN, you can find a tweet from me, I don't know, a year ago, where I was like, my first CNN for, CFAR or VGG, and I was so happy. It was, getting a 70%, whatever. The challenge that we have is that no one cared that I did that at the time. And a lot of people care about this topic now. And so this is part of AI and data ethics, which is another hot topic in the government right now. Influencers, people that are doing it, and techniques and the news. Everybody's, that 24-hour news cycle is waiting to drive something, and so we just got to be careful.
Yeah, the clickbait and the notion of funding, right? Because it all comes down to funding, and there wouldn't be hype without a need for funding. And that's the whole, my biggest problem was these companies that attempt to create AGI and all kinds of things, is that they start from very, very good intentions, right? We want to build open source AI tools and things like that. But then all of a sudden they change to for-profit agencies or whatever and collaborate with all kinds of big corporations and stop releasing the things publicly because it's unsafe. And I understand why it's happening, because it's reality, right? And you cannot continue building exciting and amazing things without lots of funding. And basically GPT-3 probably cost like millions to produce, and it's impressive, and that money had to come from somewhere. But where is that balance between clickbaiting and fueling the hype machine about the SkyNet versus providing actual benefit to humanity and research?
Totally. And I think that the title that you just used, clickbaiting versus hyping the SkyNet machine, is definitely the title for your next long Twitter thread.
I'm determined. I'll do that. We have 4 minutes here. Not sure how much more time you have, but the last topic that I wanted to touch is, and it's kind of meta because obviously you worked on Curiosity Rover. The show is radically curious, but the question that I ask people is how important is curiosity in your life, and how do you even explain it? Because you obviously are super curious, right? And you observe that curiosity across different environments. So tell us your experience with it.
Oh, thanks. Or thanks for asking me. And again, just if I don't get a chance to say at the end, hopefully too, thanks for having me on the show. And I'm a fan. You're doing amazing stuff. You're someone to look up to. And I hope all your fans and listeners know that. For me, I am curious. I have 3 kids. I have an 11-year-old son, a 5-year-old middle son, and a 3-year-old daughter. And, you know, we're surviving in quarantine right now. And they have to listen to daddy's stories sometimes about getting something to work on his laptop, where I was running deep speech the other day and retraining that as part of some work I was doing. And I'm like, it's hearing. Listen to it. It's learning to hear like our ears learn, you know? This is like biologic. And so my kids are like, shut up, you know, or whatever. But my oldest son now is at a point where he's sitting there like, it's starting to click. He's like, Dad's thing is kind of interesting to me too. And I can relate this back to my Fortnite video game and my Alexa and my this and that. And so for me, I'm starting to see, I mean, I have a natural curiosity too. I think it's an important, if you have nothing else in life and you're a successful person, maybe you could share this too with your listeners, is if you have nothing else in life, have curiosity and passion, because you'll be successful in a lot of places, you know, like because curiosity and passion, you'll be successful in life, potentially with family, and really care about what you're doing. If it matters to you, I mean, the worst part, right? You ever worked, I'm sure maybe you have, you worked in a job you didn't like. That's the worst, you know? Yeah, you did. And so that's the worst, right? Because that kills your curiosity and your passion. And then you try and get it from somewhere else, and that's just going to pull you away eventually. But if you can align your home life, your work life, you know, whatever, your fun, going to Hawaii and then thinking about data and the waves and whatever you do, how to solve coronavirus to help save us and get us out of quarantine, you know, and if you can align all that so they're all the same, you will be, what do they call those, exponential organizations? You'll be an exponential person. Yeah. And I think that's what you are, and that's what I try and do. And anyways, that's my thoughts on that.
Yeah. Amen to that. That's a beautiful phrasing of that exponential person. I haven't heard that one before. I'll make use of it.
Go for it. Put it in our GPT. Just throw some GPT-3. Put in some of my tweets, and then put in some catchphrases like that.
Yeah, perfect. That's a stunt to do.
Someone who refuses to settle for average, who has grit, a humble and hard-working soul with the audacity to dream.
Thanks, man. Really appreciate you jumping on today. And actually, I'm looking forward to have another one sometime in the future.
I would love it, buddy. You're based in LA, right?
I am.
Yeah. I'd love to post-pandemic, you know, get coffee or something. And we don't even need to wait for then. Let's Zoom again in a month or something, okay?
Sounds good. Thank you.
Bye.
Bye-bye.
See you.